Okay, Math 2 3.1 Vertex Form notes. So for starters, I want to go over Vertex Form with you. So Vertex Form is listed as, or given as, y equals a x minus h squared plus k. Okay, a is stretch or shrink. Let me see if I can spell that right. A tells you if it stretches or shrinks. That's supposed to be a little arrow, but that didn't come out very nice. Stretches or shrink. Okay, and then we have H and K. Our vertex is going to be HK. Okay, now something to notice here is that there's this negative hanging out in front of the H, but then there isn't one with the vertex. That means that the H, your X value of your vertex, the X value of your vertex is always the opposite of what it's listed as. So in number 1, if we look down here, it's got a +5 right there. Our vertex is going to have a -5 for the X value. Okay. The axis of symmetry is always equal to H. Okay. Our min, let me rewrite that. Min or max is always y equals k. But you have to decide, is it the min or is it a max? Okay, and we'll talk about that in just a minute. All right, let's look at the worksheet now. Identify the vertex, the axis of symmetry, the min or the max value, and the y-intercept of each. Then sketch the graph. Okay, so we've already talked just a little bit about the vertex. The vertex is a point like x, y. The x is going to be -5 here, right? Because it's listed as +5, but we got to flip it. And then we've got -4. And you don't have to do anything special with the -4. It stays a -4. So let's go ahead and graph that on here. There's our vertex. Okay, the 3 hanging out in front, that means that it's stretched by 3. So normally, whenever we graph a parabola, we would go up 1 over 1. Here we're going to go up 3 over 1. So 1, 2, 3 over 1, 1, 2, 3 over 1. And I'm okay with only using 3 points on a parabola for now. And there's our pretty parabola. Our axis of symmetry, I'm just going to list it as the axis. That is going to be x equals -5. You grab this -5 from the -5 in the vertex. Every time, every single time. I'll go ahead and just sketch that in there. All right, min or max value. Now we have to decide, is it going to be the min or is it going to be the max? Well, in our parabola is facing up, which means it has a bottom, right? If it was facing down, it would kind of have a top. So this right there is the bottom of our parabola. So we're going to have a min value of y equals -4. And I grab this -4 from the vertex. Okay, did I do everything? Vertex, symmetry, min or max. Oh, y-intercept. Y-intercept. You find the y-intercept just like you find y-intercepts on any other equation. You plug in 0 for x. So for here, I'm going to say, well, I've got f of 0 equals 3 times 0 plus 5 squared minus 4. This is the same thing as 3 times 5 squared minus 4, which is the same thing as 3 times 25 minus 4, 75 minus 4, and 71. So my y-intercept is 71. All right, number 1. Okay, let's move on to number 2. For starters, I want to find my vertex. My vertex is going to be a point. I'm going to grab that point from this -3 and this 4. Remember, our x value has to swap. So right now it's a -3. We're going to turn it into a +3. And then our y value just stays the same. It's just going to be 4. I'll go ahead and graph that. 3, 4. Now we have to look, is our graph getting stretched or shrinked at all? And it's not getting stretched or shrinked at all, stretched or shrunked. But it is upside down, right? We've got that negative. So instead of going up, we're going to go down. So we're going to go down 1 over 1. And just since it's easy to do, I'm going to go down 3, 1, 2, 3 over 1 also. So we did 5 points on this one. You guys don't have to do 5 if you don't want to. There's our parabola. All right, what did I find next in the last one? The axis of symmetry next. The axis of symmetry is going to be x equals 3, right? I grabbed that from the vertex. So let me sketch that in here. We might not sketch it on all of the problems, but we will at the beginning. Min or max value. This one is going to have a max value because there's a top. It's like a roller coaster. This is the top of the roller coaster. So we've got a max is y equals, what is that, 4. And then y-intercept. Again, I'm going to plug in 0. So I'm going to say, well, f0 equals negative parenthesis 0 minus 3 squared plus 4. F0 is, well, this is going to be negative 3 squared plus 4. This negative out front stays there, but the negative on the inside of those parentheses is absorbed by that 3 whenever it's squared, right? Because we've got -3 times a -3, which gives me a +9, but there's still that blue negative sign out front. And then I've got my plus 4. -9 plus 4 gives me -5. So over here I can say my y-intercept is -5. All right, that was number 2. On for number 3. We'll start off by looking for our vertex. Our vertex, we got to get our x and our y. Our x, we have to remember to swap it, or make it negative. So we got -3, -2. We'll go ahead and graph that. We got -3, -2. There we are. And then we have to look if it is stretched or shrunk. It's not stretched or shrunk at all, but there is a negative there, which means we got to look down. So just like that last one, I'm going to go down 1 over 1. And then just because it's easy to do, I'm going to go down 3. 1, 2, 3 over 1. Then I can draw my pretty parabola. Those are terrible arrows. Oh well. All right. Next up, what was next up in the last one? I think it was axis. Yes. The axis of symmetry. The axis of symmetry is always x equals the x value of your vertex. I'm highlighting those because those all, the numbers that I'm highlighting will always be the same. Next up we have min or max value. Well, this one's going to have a max, just like number 2. The max is going to be at y equals, not -3, -2. Okay, and the reasoning there again is because our parabola is facing down, so it has a top. It has like the top of the roller coaster. All right, and then we have the y-intercept, and I just have to plug in a 0. So I'm going to have f of 0 equals -0 plus 3 squared minus 2. That's -3 squared minus 2. This negative is going to stay out front because it's not inside those parentheses. So there will be that negative, and then 3 squared is 9 minus 2, which gives me -11. And also, if we look at our graph, -11 would make sense. It would be all the way down here, but it would make sense with our graph. Okay. Number 4. We'll start off with the vertex. We have, we're going to have positive 3, negative 1. I'll put that on the graph. There we are. Next up, I'm going to have the axis of symmetry. That is x equals 3, because those all 3's are the same. Ooh, let me go back and talk about stretching and shrinking. There's nothing in front of the parentheses there, so it's just going to be a plain old parabola that's facing up. So whenever I graph it, I can go up 1 over 1 and then up 3 over 1. There we are. Max or min? This one's going to have a min. It has a min because it has a bottom, like the bottom of a cup. So I'm going to say, well, that is y equals negative 1. And then for the y-intercept, I got to plug in a 0 again. So I'm going to have, well, f0 equals 0 minus 3 squared minus 1, which is negative 3 squared minus 1. Now, because that negative is inside the parentheses, it's going to get taken away by that squaring. So I've got 9 minus 1, which gives me 8. So my y-intercept is 8. Alrighty. Now for the second part, use the information provided to write the standard form equation for each parabola. Well, let's just copy down what that standard form that I gave you right at the beginning was. It was y equals a x minus h squared plus k. So our 7 is going to be our h, our 5 is going to be k, and then y-intercept, we'll have to deal with that in just a minute. So we can plug in for h and k and we get y equals a x minus 7 squared plus 5. The y-intercept we could write it a little bit different. We could say, well, this is a point whenever x is 0 and y is 54, right? So rather than doing it like I did up here, where we plug in the 0 for x and we have to find it, we don't know what a is. So we're going to plug in this point and find a. So I've got 54 equals a 0 minus 7 squared plus 5. I've got 54 equals a negative 7 squared plus 5, which gives me 54 is, well, negative 7 squared is 49. So I'm going to say, well, 49a plus 5. I'm trying to solve for a, so I'm going to subtract 5 from both sides. This gives me, well, I can cancel those 5's out. This gives me 49 equals 49a. Whenever I divide both sides by 49, I know that a equals 1. Okay, so I'm going to take that a equals 1, and I'm going to plug it into this equation right up here, the equation before I plugged in the point. So this is going to be y equals 1 x minus 7 squared plus 5. And if you wanted to, you could get rid of that 1. So y equals x minus 7 squared plus 5. There's your answer. Alrighty, number 6, last one. We've got y equals a x minus 7 squared minus 3. Okay, I got this negative 7 from right here, and I got this negative 3 from right there. All right, my y-intercept, I want to write that differently, just like I did on the last problem. My y-intercept is negative 52. I could say, well, that's the same thing as 0, negative 52. And now I'm going to plug that into our equation. So I've got negative 52 equals a 0 minus 7 squared minus 3. This is the same thing as negative 52 equals 49a minus 3. This is the same thing as negative 49 equals 49a, right? Because what I did there is I added 3 to both sides. And now to finish off, I'm going to divide both sides by 49 because that's the coefficient of a. And I get negative 1 equals a. And just like in the last problem, I'm going to plug this into, where is it? This one up here. So whenever I do that, I get y equals negative 1, x minus 7 squared minus 3. And I can drop that negative 1. Well, I don't really drop it. I drop the 1. The negative stays there. And I get y equals negative x minus 7 squared minus 3. And there's my answer. All right. You will not always necessarily get A being 1 or negative 1. Sometimes it can be like 5 or 3. So just be wary of that. All right. That is the notes.